What up, everybody? It's your boy Jester James here, coming at you with that forensic video that we said we were going to get to. So here we are at that case of the stolen Szechuan sauce. In some of the previous videos, I kind of alluded to this just because I was using some of the data here. And just right off the bat, before I get into it, all credit, hands down, go to the DFIR Madness folks, specifically, or I guess, James Smith. Awesome name, James. I'm also James, so more power to you there. So that's DFIR Madness. Shout out to the folks there, James and his team, for creating not only an awesome blog and website to get folks going, but also for creating some data for us to play around with. So we've got a fake case, but it's modeled around a real-world case scenario. And it's the case of the stolen Szechuan sauce. Now, I'm not going to go too deep into this because I very much would like you to go and tackle this on your own, or go to the dfirmadness.com and check out the actual case in its entirety and everything. But what I'm going to do is basically get straight to the questions to answer and start tackling some of these right off the bat and showcase how we can go and analyze the data that we're given. And right off the bat, so I've gone and copied and pasted these questions to answers to this Google Doc over here. And there's even a client interview included. So again, big shout out, awesome job to James and his crew here at DFIR Madness for creating a very awesome case with some context as well, and making it real and legit here, because it's great because he's got the Rick mannerisms in the text here as well, like the belches in the middle, and you even got that idiot Jerry plugged in there. So I really do, I had fun taking a look at this data, and basically the idea in this case is really fun because it's Rick and Morty, and I'm a big fan of Rick and Morty. So awesome show and awesome characters to model your case around. Right off the bat, you can scroll down, download the data that you want to be downloading. For us right now, I'm just going to be looking at the disk images. So that's these EO1 files here, DC01, and then desktop disk image. And let's get to it. So I've gone and copied and pasted questions here right off the bat. So I've got the data here. I downloaded it all, but we're only looking at these disk images here. And I've already tossed them into Autopsy, and I also tossed it into FTK because one of the things that I wanted to do is grab that registry. So right off the bat here, let's toss it into Autopsy. If you'd like me to go and make some content around Autopsy, just let me know. Leave a comment below, or hit me up on Twitter and things along those lines. But Autopsy is a great free forensic suite that is awesome for instances like this where we have some disk images to look at, and we can parse out a bunch of artifacts from using Autopsy, and it's really great there. But I also want to showcase some of the more manual forensic ways to kind of extract some artifacts. So right off the bat, let's just get to the questions here. So what's the operating system of the server? And then what's the operating system of the desktop? So I've actually worked on this case already a little bit and kind of had my time with it, and honestly I had a lot of fun going through with it. But I wanted to record a video a little bit just detailing some of the quick things that I can go and show y'all about kind of analyzing the data here in an initial triage. So I've gone, say we have the EO1 files here. So let's start with, I guess, the server. So DC01, here's the EO1 file. We can toss it into Autopsy. So you'd add data source, right? Disk image, hit next, and then you basically go through it, and it'll also get you to a screen where There's ingest modules, for example, so things like recent activity, file type identification, and other parsers, Plazo. You can kind of choose which ones you want to run, but the basics are basically the standard ones that you would think that you'd want. For example, email, keyword, EXIF, embedded files, extension mismatch, file type. Basically, you can check all of them except for like Android analyzer and maybe the drone analyzer and the GPX parser as well. Like, because we're not looking at drone data, we're not looking at Android data, and we're not looking at any geo data either. So, right off the bat, let's just go to the data sources and get these easy ones out of the way. So this is the So this one is the server. So that's Windows Server 2012. There you go, Windows 2012, and the desktop here. Also, Windows 10 there. There's that. What is the local time of the server? So you can go into Autopsy, actually, and you can go to Operating System and Information. So that you can actually, so we have Autopsy, but I did say I wanted to kind of show how we can kind of do some more manual forensics here. So, for example, say we don't have a forensic suite. Say we just have, we don't have a forensic suite, but we do have, say, like FTK Imager, and you just have your image. So you mount your image in, say, like FTK Imager, or you can use like Arsenal Image Mounter. I'm just using FTK real quickly. So take the registry files that we want, because what we're looking for, the time of the server. So that is going to be in the Windows registry. So the registry is located at System32 under config. So if you go to the partition with the Windows drive on it, Windows, you go to System32, and then you go to config. And here's that folder there. And what you're going to extract system, software, security, and SAM. So those are all the registry hives that you'd need that are the main registry hives right now. And as you can see, there's also some like log files too, and then there's like file slacks. So when the image was taken, there's probably the registry hives are going to be quote unquote dirty, and you'll kind of see what that means as I get into that. So you can right click and export the files. I've already gone and done that for the server in the interest of time. So here are the registry files that I kind of extracted there. And then, so next thing, the way to go about looking at these registry files, my advice would be to download Eric Zimmerman tools, specifically Registry Explorer. So you can go to Eric Zimmerman's got his solid website. Eric Zimmerman's a legend for releasing a bunch of these open source tools and really providing and giving back to the community here. I've learned a lot of my forensics based off of Eric Zimmerman's tools without necessarily using forensic suites. However, adding forensic suites on top of that knowledge really solidified the foundations. But so you can download all of these tools that Eric has provided us in a single zip. However, just for this instance, what we're going to do is just download Registry Explorer here. And that's to allow us to go and look at the registry, because we want to answer this, what was the local time of the server. So here's Registry Explorer. I popped it open, and then you can just drag and drop the registry hive in there. And the one that we want, so we're looking for the time zone. So if you're not, you can Google which registry key has time zone, and very much like everything else, right? If you don't know something, you Google it, or if you have a question, you Google it and you do your due diligence here. personally, I've had a document that is a living document ever since I started learning, and I can go here, and I'm going to be publishing this when I feel comfortable enough that it's got enough Windows or digital forensic artifacts to kind of get folks going. And I do want to fill it out a little bit more with context around some of these keys and things along those lines. So like right off the bat, time zone, here's that registry key. It was in that other post as well. So I'm going to go there. So we can go there, but also it's already bookmarked. Thanks to Eric here. We got time zone information. Time zone key, Pacific Standard Time. And that active time bias too kind of matches us up. So PST. Now, next question, was there a breach? I'm just going to automatically say yes, because, like, why would you ask that question if there wasn't? And also, there's a bunch of these preceding questions. Initial entry vector, I'm not sure yet, because that's more of a higher level question. Malware used, process was malicious, IP address, malware on the disk. So also, we can just look over some of these questions right off the bat. Now, if we go back here, and James did say that if we're only looking at the disk images, answering these is going to be a nightmare. So I'm not expecting to answer all of these questions currently. Not at least with the disk image, but not with the disk images alone. For the most part, I'm 100% sure that I'll be able to answer these malware questions while looking at the memory. So if you go and you make sure y'all download the memory for those, the DC and the desktop, because usually you'll be able to catch those malicious processes in memory, especially when you're dealing with things like Cobalt Strike and Metasploit, where some of their payloads actually are going to be found in memory. So there's that. But we're only looking at disk images for now. What malicious IP addresses were involved? Pieces of adversary infrastructure, network layout, architecture changes. Did the attacker steal Szechuan sauce? All right, and then we also have some bonus questions here and like Beth's secrets. Like you can also see an autopsy already. If you're just browsing autopsy, going through things here and just going and looking at what autopsy is giving you automatically, you can see things that are with reference to obviously Rick and Morty, you know, Jessica, portal gun plans, loot, no Jerry, Beth's secret. So like there's that Beth's secret text file. And we also, so that's a recent document and we can find the file path for that. So we can go and look at it in autopsy here and go to that file, but I'm going to do it in FTK just because I want to kind of keep that file path. So that's, where was that? So that's C, file share secret. So I'm going to go back from the registry here. C, file share secret. So here we have, like, obviously these are quote unquote secret files. Beth's secret says space Beth is the real Beth. So there's a little bit of a spoiler for y'all who watch Rick and Morty, though it's not really a spoiler, but this is what the text file currently says. No, Jerry, you are a disappointment. Portal gun plans, so how to build a portal gun, be intelligent, obtain portal fluid, do intelligent things. You didn't think it would be here, did you? So now this is interesting, though. So, like, and then you got, like, Szechuan sauce. It kind of looks like a recipe. Now, so Beth's secret. So I do know some of these things here is that these files are potentially manipulated. So we can't really trust these. So, for example, going back into the question here of, can you recover the original file about Beth's secrets? So, obviously, the file that is on the system without us going and looking at the changes that would have been made to this file, Space Beth is the real Beth. So this, I assume, has been edited already. And we can kind of go and see how that's changed. So if we actually, let me actually go in here, take a gander. Autopsy may. So here you see autopsy. Now, this is why I didn't do this at first. Autopsy and like most forensic suites really does make it easy for you. So you can see that this is the old secret_Beth. So this was the original file, and you can see the file that was edited that we saw in FTK, and this is where it's critical that, and this is why I get very paranoid when I'm doing my forensics, and I guess I'm paranoid as it is, but you can see, so I usually I don't do my forensics in FTK. FTK you use to extract artifacts like registry, autopsy. Prime example here really tells you, look, answer that question. Earth Beth is the real Beth, not Space Beth is the real Beth. So that's not right. So the original name was secret_Beth, right? All that was capitalized. And also BT dubs, there's a bunch of different ways that you can go about answering these questions and finding the answers to these data. Original contents, so you can go back here, text, Earth Beth is the real Beth. So it's not too big of a surprise there that the change is that Space Beth versus Earth Beth. Also, spoilers for those who haven't watched, I think it's season 3 of Rick and Morty. Might be season 4. I don't remember off the top of my head. Finally, what file was time-stamped? Okay, so that's cool. We got to go and do some timestamp analysis. Actually, I think we saw something here as well just by... So you can see... So another really awesome thing about autopsy, right? It does a lot of the work for you. Now, I caution you folks when you're using forensic suites is these tools are awesome. However, at the end of the day, you're going to have to explain how the tool has gotten the data, how you got the data, and you can't just say, "Oh, I got it from autopsy." You actually have to kind of go and explain that in a little bit more detail as to how you'd actually go and look into that. So, for example, let's go and take a look. So, off the bat, my initial reaction was, okay, if that file was edited, the original one would probably be in the recycling bin. And here it is. So we have the R file for that. So we don't know what this autopsy's already parsed it, but say we go into FTK, right? Add that image file. And I think that was, so that's on the C drive, EO1. So if we go here, and then we go into that recycle bin, right? That file should be there. So we actually have both of them here. So here's file share secret_Beth, and then Earth Beth is the real Beth. So the original file was deleted and tossed into the recycling bin, and then a new file was created, and it was Space Beth is the real Beth. So if we go in file share here, secret, right? So you have no, in FDK, right, you can't see that this file has been edited or anything like that. You can only see like date modified, but you see Beth underscore secret, that's different than the original file, secret underscore Beth. So that's a critical component there. Also, like the question is another way that you can kind of get, you can go into how you're looking for that as well. So the fact that the original file, the fact that that's a question, I know that I know that the original file in this file share then is not valid. And you can see, so the I file details the information about the file when it was actually not deleted. And then the R file contains the contents, as you can see. So here's that file path originally. And then we can also see some of the date modified dates here. So 19 and then 18. So that's interesting. The fact that that's the 19th. So if we go to the original, so there's that. So that's 18th as well. So that's interesting. So that's an FDK, right? So if we go back to autopsy, right? Go back to the analysis that we were doing there. And again, that's just me explaining how you can go and validate your findings from a tool, going and using other tools. And when you go and see that repeated, repetitious evidence, then you're seeing validation for your findings. So cool thing about autopsy right here, right? We got all the we got the timestamps we need to kind of take a look. 18, 23, 47, and so these actually, so that's 1839, 1823, so that's IE. And then Beth underscore secret, 1935, 1935. So actually what's interesting here, right, so 18, so theoretically, right, this is actually after the timestamps for this file. So this is the original file, actually. This file should actually be, the timestamps would make more sense. This timestamp would make more sense on this file because this is the file that was edited, right? Yeah, because EarthBeth is the real Beth. So with that, right, I'm going to go and say, for now, what file was time-stamped? So I'm not confirming this yet, but just because, based off of just that initial look through autopsy, I'm going to go back to this, because this is the last question, so I don't want to go backwards here, but that's what I'm going to say for now, and we can go back and validate and look at it later, but so there's just looking at the high-level stuff that we can kind of get with the disk images alone. Remember, we're not expected, and we're not looking to go and answer all these questions with the disk image alone. But I'm starting off with disk image alone just because I think it would be interesting. We can go here, operating time system. So you can actually go here. And autopsy as well, right? Like, you don't need registry explorer. So like, autopsy is not my primary forensics tool. I have not used autopsy as much as I have used, say, Eric Zimmerman's tools or other tools, more manual forensics tools. I have not been a forensic suite forensicator. So I was mostly taught how to do it more manually, but forensic suites, they make life easier. For example, you can do everything in autopsy. So you can go, for example, say, let's go and see if there's another question we can answer using registry. So process, what was the initial entry vector? What was the network layout of the victim network? Okay, so we can go and get like IP addresses, for example. So I'm gonna go back to my DFR companion. Go to, okay, so here we have system, control set services. So this is gonna give me the IP address and the network information for the images. So system, control set services, TCP. So we're already in the system hive, control set. It's in one of them. Let me see, services, and then TCP IP. Services. Scroll down, scroll down, scroll down, scroll down. There we go, TCP IP. So you got more values there. TCP IP parameters. So here we have host name as well. Name server, domain. So it's on that C137 domain. We're gonna go to interfaces, right? There we go. And now we get some IP addresses. So that's the local host. There's the name server. So here's an IP address. And it's always good to just get your basic system information down, just so you're able to recognize what host's talking to what. So if we got our IP addresses, I think we can copy and paste that. Close enough. Well, I don't want a table, I just want that address. So here's, dang it. Okay, classic. Weird ways to copy and paste with James, LOL. 10.42.85.10. And that is going to be the that's for, what was the other one? Yeah, so that's for the DC. Closed out of that, RIP. Can go back in there though. Parameters, interfaces. Also that subnet mask. 255.255.255.0. So actually what we can do, 10.42.85.0/24. So a little prerequisite here, if you haven't gone and learned about subnetting or IP addressing, there is a video that I had made previously on that. You can check it out. Check out the blog post if you want. We go. So all you need to know about subnetting and networking. So that's will explain the subnet masks and basically the notation that I have here. But basically I just used CIDR notation for the network there. So that's going to be the DC, domain controller, and then let's go and check out that other interface if it's got the same. So this one, 10.42.85.10. Alright, so there's that. And now what I want to do, so that was the DC. If we go here, so this is interesting. We got multiple partitions here. So there's that main one, Windows, System 32, and I know where some of these files are and some of these artifacts are just from the fact that I've done this a lot of times. So the more you do it, the more the locations and things will basically just get drilled in your head, and then you won't have to look at the companion as much, but I still have the companion because I can't remember everything. And also just because I like to double check. So here's that system high. We're going to do the same thing here. So here's that control set 1. Services, TCP/IP, QRS, TCP/IP, parameters, interface, 10.42.85.10. So that's that name server 2, 10.42.85.1.5. So there's that. See, both of those hosts are in the same, they're in the same subnet. So let me actually, so there's 85.10. And that's the DC. But 10.42.85. I think it was 115, right? 115? Yeah. And then there's the 100 gateway. So there's just that one subnet, it looks like. So I'm going to go 10.42.85.0/24. So there's that. Now, the more we work through this, the more we'll be validating the answers that we're getting here. I'm just gonna say yes there, and then so there's that. Let's see what else we can potentially do. Malicious IP addresses involved. Disk image alone. So malicious IPs. So now, off the top of my head, I'm just thinking about some of the artifacts that I would kind of go looking for that would kind of detail some relevant information there. So, assuming, let's go with some easier stuff. Let's go straight to like say web history. Autopsy is taking care of web history for us here. Let's just go take a look. And you can go, so another really awesome thing here with autopsy. So earlier I was talking about how it's not that you shouldn't trust the forensic suites. However, you should always validate your findings when you're going and using your tools. But autopsy here gives you a source file, which is really awesome. So you can actually go into, say, FTK and extract the data manually, and then you can go and use things like, say, Eric Zimmerman's tools to go and parse them. For example, like, let's say that web cache file, right? Web cache vo1.dat. So we can go and be like, so I know what tool I would use, but if I were you and I didn't, we'll go and say like web cache vo1.dat viewer. Like, there we go. And there it is, IE cache view. There's one. So that's Internet Explorer history. That's a prime tool by Nearsoft. Website looks sus, but this is a tool and it's legit that I've used. Let's see if there's other ones. ESC database viewer is another one that's good. I've used that. IEF and Axiom. Yeah, ESC database view is another one from Nearsoft. But, so we have autopsy here. So right off the bat, we're just looking here. So it's interesting. You can see that there's the files that are actually on the system are being looked at through the browser, it looks like. So there's Morty's social security number, interestingly enough. Just because I'm curious, I would very much like to go and see what that looks like, because I I think that's funny. So let's go and take a look at that. That was users, that was Morty. Where was that? Desktop. Well, so I also just like playing around here, looking at what's actually in the image just because it's funny. Thoughts. Jessica is on his thoughts, of course, because Morty is in love with Jessica. All right, so here's like my social security number. There's that file we're looking at, 58499. Classic. Plans. Marry Jessica, like I was saying, he loves Jessica. Jessica, got his own protocol. Jessica, go on his own adventures. Ask Rick about cloning Jessica. All right, Morty, you're getting a little sus there, boy. Portal gun, classic. I got some metadata there a little associated with that. But, so that was fun pivot there. But let's go back to that web history. So you can go and do there. Just keep scrolling down and all right. So here's something interesting. Usually you don't have an IP. You don't just go and navigate to an IP address. That's what DNS is for. That's why we go and use. That's what it should look like. Something like HTTPS. Not like. Also, there's no S here, so that's sus. Also, I'm surprised that that's a public. I think that's a public. That's a public IP. As well, so that's not even like a local host. It's not 127.0.0.1, so it's not like interfacing. So let me see if I can extract or at least copy that. Close. So I'm just curious, right? Like there's another thing. So like there's different tools that you can use. Personally, I have the habit of using MaxMind, MMDB. So this will give me details about this IP address. Yeah, the classic. It's Russia. So that's obviously bad. And I think I saw another one. 194.64. Is that the same one? Yeah, that's the same one. Okay. So there's one IP address. Obviously that's Russia. So that's I have the bias of thinking that's bad because I don't live in Russia, but Russia has been, well, I'm not gonna get into that, but you can Google Russia and cybersecurity and cyber attacks. Curiously enough, actually, as well. So there's more things that you can do, and this is a fun thing about forensics and things. There's so many different ways that you can go about doing the same thing. I'm going to go and look at this IP, see what pops up. And they flagged it as malicious, at least 3 folks. Actually, it's interesting here. Looks like it's not. I'm not sure if James and the DFR Madness folks actually went and... Ah, there it is. Okay, so we got some Google results around it. And obviously, yeah, it's in the answers there. So I'm not going to click into that, but you can kind of go into detailing there. But so obviously that IP is relevant. So I'm going to note that. I don't know if that's the malicious IP address. Also, I don't know if that's where the malware was, but so the fact that it's browsing to that address makes me think that that's the IP that had the malware. So my initial thought here, and also you want to make sure you kind of note here, found in IE web history. Russian IP. So also so whoever browses to that, that's going to have something malicious on it. So actually we can go, I think we should be able to, I think I saw in the other ones on the bottom more details with that file path. So yeah, there's like favicon.ico that looks like it might have been downloaded from there. Interestingly enough. That could be sus, it could not be sus, I don't know. Let's see. So you can also go back. Sorry, if you keep scrolling through it, right, you're gonna see classic like Rick and Morty meme stuff. So some of the search history, Wikipedia, Japanese Wikipedia, interesting. Politics, Wikipedia, Portal Gun, Rick and Morty fandom. So classic standard stuff there, but based off of the disk image alone, the disk images alone, we've got, I'm actually pretty satisfied with the answers that we've got so far, just by looking at the disk images by themselves. Let's see what else we can kind of look at. So initial entry vector. Initial entry vector. So I would like to see if I can find that file in downloads or something. So there's user administrator. So the user that's doing that is the admin here, and that's for which host is that? That's the DC. So let's go to the DC, kind of see if we can find that file by chance. Also just poke around, see what we can look at. Actually, we can also pull the registry files here. So, fun fact, let's go back to our DFR compendium here, our companion guide. So here's some really awesome artifacts that really go in detail some of the basic things that you can go and triage for. One of those things, there's prefetch files, LNK files, jump lists, but Amcache is a solid example of one of the things that you can go and take a look at that shows recent programs and programs that have been run and leveraged. So let's go extract the Amcache hive and load it up here and take a look. And there's another tool that you can use to look at that registry. And there's another tool that you can go and use to look at registry files called RegRipper. Let me download that as well, so that you can download. So I don't need the Linux binary. I want the Windows download. .0 lit. Let's just download the file there. Honestly, I have to build like an actual forensic workstation with all the tools and everything. I'm just used to using my work laptop because that's got all my stuffs there, but I gotta use one for my forensic Jester James content. Also, I hope y'all are enjoying this and it's worth your time. If not, let me know. I won't do reruns of things like this. But so RegRipper, here's one. There's that executable. Fender, Smart Screen, Classic, more info, unknown publisher. Look at Windows protecting us. Okay, I know this is a legit file, but shout out to Windows. Thank you. Run anyway. Why? Because I know Eric Zimmerman, our legendary friend that I have never met, but I wish I can, and he's awesome because if I did meet him, I would give him a great hug because he's taught me a lot, and I've never met the guy, but using his tools has taught me a lot too. So we wanted to go to that Amcache. So let's go to Windows App Compat. So Amcache, also known as app compatibility. So this is a portion of the registry that has all of the necessary elements for like application compatibility, as the name suggests, App Compat. So Let's go and get the app compat for... We can go and get it for both of them. So we're going to need to do that. So let me go create a new folder here. VM caches. So here's a really important thing. When you're extracting data raw, you want to make sure you organize all the evidence. That way you're not getting confused if you have to go take a break and come back or anything like that. Also, I want to keep track of the time here. I think we're at 45. But here we go. Windows, app compat. Windows, app compat. Programs, app cache.hive. And you can actually, I think we can actually look at it here. But this, like going through this here, it's like you would go and look at it in Registry Explorer. Personally, when I prefer to look at it in RegRipper just because it's easier to parse it. And this one is, so that's the desktop amcache. So I'm going to do desktop, save. Then we need to go to the DC, Windows, app compat. Same thing here. Extract the file. RNM, Rick and Morty, amcaches, and this one is the DC. And so here's our hives here. And we got registry, we got RegRipper open up. Gonna go and have the DC amcache parsed. Right, because we did the DC first. There's DC amcache txt. So that's going to, so you can see, this is going to run RegRipper, and then it's going to give me the report that's going to parse that. Here we go. We can see those files there. Looks like a bunch of DLLs related to VMware, which makes sense. I assume our pal James made this in a VM. They all look like VMware. So here's some, okay, still VMware. Scrolling. Okay. Still more VMware related stuff. Not seeing anything key or relevant right now. We still, alright, so all still kind of normal stuff. I'm not seeing anything screaming or jumping out at me. Might be scrolling by too fast, but I don't think I am. Alright, so there you go. VMware tools. Yeah, those are basic, so that's the DC. Not much there. Let's try the desktop. Also, I guess we don't have to specify what file or what type of hive we're parsing. In RegRipper version 2, you had to do that. I guess now you don't have to. Alright, here we go. Now we've got some more interesting stuff. So that's like inventory. Still nothing sus there. Compitel runner. Core updater. There's like things there. 919. Yeah, so we've got like, so here's, so that's like 7-zip, but that's in VMware tools, so not too sus. These things, which are in like, those seem like sus. Compitel runner, not sure what that is. So I'm no Jedi Master, but I don't know what all of these like standard Windows files are. So that's Windows compatibility telemetry. That's what that file is used for. And you can always go and double check these too. Like, it's cool that you got the hashes here. So now I can pull the hash and I can verify if these are the legitimate hashes. System 32 core updater. There's another one. Actually, what is that core updater? I assume that's the updater. Core updater Windows. Not exactly fully sure there. Don't get a full answer. Let me go to the old LOL bins. Sweet. These folks are awesome because they basically go in and detail some of these are the living off the land tools that you can potentially use. So attackers, instead of going and downloading malware through the browser or something, they can use some of these executables to kind of do stuff and do more malicious stuff using tools that are already installed on your OS. But if I go here, we got this core updater file. So that's in System 32. The other one also is sitting in System 32. So one of the things that you always have to watch for, right? And this is kind of like IR or threat hunting basics here. So a lot of attackers, they hide their malware and files in places that the normal user is not going to look. So they're going to look at like System 32. So like, for example, open with toast logo.png. I don't know why this is there. Why is that there tile empty? I don't know why that's in there either. All these DLLs, some of these could be malicious, but can't really go and do that. But we're looking at the AMCOM cache here. The fact that it's in the AM cache though is interesting. Run that hash. See what happens. All right, so that's Metasploit. That's bad. So there's one bad thing, and you're using AM cache. AM cache there. Okay, okay, if there was malware, answer the following. What process was malicious? Okay, so this malicious, toss that in there. Interestingly enough,